Okay, let's talk about Valid Palindrome. This one comes up all the time at places like Meta, Microsoft, Uber, and there's a reason for that. On the surface it looks straightforward, right? But the difference between a possible answer and a great one. That's what we are going to dig into today. So the problem boils down to this. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome, or false otherwise. Let's see what that looks like in practice. Given S is equal to a man, a plan, a canal, Panama, the expected output is true. After removing non-alphanumeric and lowercasing, Canal Panama is a palindrome. Got it? Good. Before I show you the approach, take a second and think about how you'd solve this. Then let's compare. Okay, let me show you what's actually happening here step by step. Let's look at the example. Given S is equal to a man, a plan, a canal, Panama, the expected output is true. After removing non-alphanumeric and lowercasing, Canal Panama is a palindrome. And this is the key part, use two pointers moving toward each other to avoid nested iteration. Once you see this visually, it kind of clicks, right? The algorithm is basically doing exactly what we just traced through. Now here's where it gets interesting. Use two pointers moving toward each other to avoid nested iteration. Think about what that means for our approach. First, use two pointers starting from the beginning and end of the string. Then, skip non-alphanumeric characters and compare lowercase versions. Next, parse the input and identify edge cases. And finally, apply the two pointers technique. That's it. Simple once you see it, but powerful. Let's write the actual solution now. We start by defining our function that takes self, S. We use a while loop here because we don't always move forward. Sometimes we need to adjust before continuing. At each step we check our condition, and the moment we find the answer, we return it right away. No need to keep going. Notice the two pointers, left and right, working toward each other. That's the classic pattern. Nothing extra, nothing unnecessary. This is production quality code that does exactly what we discussed. Alright, let's talk about how fast this is. Time complexity, O(n). Why? We make a single pass through the input. Space, O(1), because we use only a constant amount of extra space. And here's the cool part, this is a go-to problem at Meta, Microsoft, Uber, and the pattern you just learned, the two-pointer technique, shows up in problems like 3-sum, remove duplicates, and container with most water. So you didn't just learn one solution, you learned a technique. If this was helpful, subscribe because every video in this series builds on the last.